Hey guys, we're going to look at derivatives of trig functions. So usually you do all the derivative stuff first and then you come back and kind of apply it to trig. But we're going to need these trig functions and knowing the derivative of some of these, and we'll get into a little bit more later on. But these are just the two basic ones. So I'm going to go ahead and show you how we derive these derivatives for the trig functions. So what we're going to do first of all is that we're going to look at some of these trig identities that you may have forgotten about. So remember that the cosine of A plus B is the cosine of A cosine B minus sine A sine B. And then the sine of A plus B is sine A cosine B plus cosine A sine B. So this is going to help us out when we are using the difference quotient. So that's what we're going to use. We're going to use the difference quotient to find f prime. So then every time you see sine x, you'll know that the derivative is blah, blah, blah. Let's get started. So I'm going to try to find f prime of x. So remember, f prime of x here is going to be the limit as h approaches 0. So this is the difference quotient, remember, of f of x plus h minus f of x, all divided by h. So what we're going to have is the limit as h approaches 0 of sine of x plus h minus sine x divided by h. So now you can probably tell why we need to know that trig identity. So this is going to be the limit as h approaches 0. So I'm going to use this trig identity now. So this is going to be sine x cosine h plus cosine x sine h, and then minus sine x, and then all divided by h here. What we're going to do now is that we are going to do some rewriting and dividing out. So I'm going to rewrite this with this sine x in the middle here. So I have sine x cosine h, looks like cosh, but it's cosine h, minus sine x, and then plus cosine x sine h, all divided by h. And so what you'll notice here is that I have a sine x and a sine x in both of those, so I can divide it out. So I'm left with the limit as h approaches 0 of sine x times times cosine h minus 1 plus cosine x sine h, all divided by h. Actually, let's go ahead and separate those out. Run a little bit out of room. Divide this side by h and this side by h. I'm going to go ahead and divide those two out. So remember our trig identity when we looked at the limits. So the cosine x minus 1 divided by x. Well, it has to be the same. Like all these variables have to be the same. It has to be h, and h. All works out there. So remember that is going to approach 0. And then the limit of sine x over x approaches 1. So I end up finally, as I take the limit, I'm going to have sine x plus, oh, no, not sine x, excuse me. Erase this, sorry. Ooh. This becomes 0. That first part becomes 0, and you're left with just cosine x times 1, so cosine x. So the derivative, f prime of x of sine x, is cosine x. Now let's look at the cosine of x and see what the derivative is. So I'm going to use the difference quotient. So I'm going to take the limit as h approaches 0 of cosine of h plus x minus cosine of x divided by h. And so therefore, I'm going to rewrite that with the trig identity that we talked about at the very beginning. So this is going to be cosine h cosine x minus sine h, sine h, sine x, and then minus cosine x divided by h. So again, I'm going to do some rewriting. So that's going to be the limit as h approaches 0 of cosine h cosine x minus cosine x minus sine h sine x. And I'm going to go ahead, I'll go ahead and write it all divided by h. So here I'm going to factor out cosine x from this first two. So right here, I'm going to factor out the cosine of x. So I have the limit as h approaches 0 of cosine x times cosine h minus 1, all divided by h, minus sine x, sine h sine x divided by h. So now you can see, again, we kind of get in the same situation where you have the cosine of h minus 1 over h, and that is going to approach 0. This part approaches 0, and then you have the sine x or sine h times sine x divided by h. So this part right here approaches 1. So what happens is after you take the limit, when you're taking the limit, that becomes, this first part becomes 0 minus sine of x, 1 times that, so 1 times the sine of x, which is just negative sine x. So what we're going to do is we're going to look at a little bit different way to write derivative. So it says d over dx. So that's the derivative with respect to x. So x is the variable that we're looking for. So if you have multiple variables in here, you're just finding the derivative with respect to x when you write d over dx. So you would call that d dx of sine x. So that is just cosine x. And then the derivative of cosine is negative sine x. All right, so now this is actually the easy part, is doing the example. So the long part is already over. So we want to find the derivative for these with respect to theta. So I really am wanting to find d theta of 4 sine theta minus theta. So that's another way to write finding the derivative. So the derivative of 4 sine theta is actually 4 cosine theta. And then the derivative of theta is just 1. So remember, that's like x. So when you find the derivative of x, remember you take that exponent, you knock it down by 1, and then you bring that, you multiply it out front, so you're left with 1 is there. So 4 cosine x. So that's just the derivative there. 4 cosine theta minus 1. Derivative there. So to find the derivative with respect to theta of 2 theta plus 3 cosine theta, you're going to end up with 2 and then minus, because remember that the derivative of cosine is negative sine. So we're going to be 2 minus 3 sine theta. So that's the derivative with respect to theta. All right, so lastly, we want to know at what values of theta does the function f of theta equals theta plus sine theta have a horizontal tangent on the interval of 0 to 2 pi. So remember, just to make sure that you recall, a horizontal tangent is whenever the derivative is 0. So I want to find f prime of theta of this function here. So the derivative of theta is just 1 plus, then the derivative of sine theta is cosine theta. So that's the derivative. Then I'm going to set this equal to 0. So 0 is equal to 1 plus cosine theta. And then I end up solving for theta. And so where is the cosine of theta equal to -1? So I'm thinking that that is going to be at pi. So pi is equal to theta. So at pi, between 0 and between 0 and 2 pi, you're looking at the horizontal tangent being at pi, which makes sense because that's wherever it's going to come up to its peak. And so it's going to have a horizontal tangent there. So that's it for derivatives of these trig functions of just sine and cosine. These are something that you'll definitely want to make sure that you memorize. So the derivative of sine is just cosine, but the derivative of cosine is negative sine. So you want to make sure that you remember that negative sign. So whatever it is that you need to make sure that you remember that by that's what's going to help you, because we're going to have to be able to just spit these out in rapid fashion later on. So that's it for derivatives of trig functions, just these few select trig functions.